Okay, and I will start to share my screen. Just a moment. Perfect. It's working. Okay, so in the last class, we start to describe about some diagnostic horizons. We start to discuss about some surface diagnostic horizons. If you remember, we start to discuss about the world reference base for soil resources, that one of the two systems, two soil classification systems that we use in this course, okay? And we saw some of these diagnostic surface horizons. We discussed about the folic and histec horizons. They both are organic horizons, so they present a high content of organic carbon, at least 20% of organic carbon in these horizons. The folic horizon is an organic horizon that's found in cool areas or dry areas, or some areas that we can't find any evidence of fluidation, of water table influence or tidal water influence. So they are formed in well-aerated soils. The diagnostic criteria for these folic horizons is that it shouldn't present a high number of days with influence of water, at maximum or less than 30 days, 30 consecutive days when you have a moist years and normal years, okay, without water, and you should present at least 10 centimeters of thickness. And we saw also the histec horizon, that also is organic horizon, but it's saturated by water. So the histec horizon, it's formed by water table influence or tidal water. So the organic matter here is accumulated by the influence of water, is the opposite condition from the folic horizon. In the folic horizon, the organic matter, it's formed and it's accumulated by the dry or cool climate. And here, the histec horizon, the organic matter, it's accumulated by influence of water. They both are organic horizons, but they are formed in different conditions. The the primary difference between them is the soil moisture regime. Here, the histec horizons, we saw aqueous regime with a lot of water, and the folic, we can see the other soil moisture regimes, but we can't see a high influence of water. It's not a saturated horizon. The diagnostic criteria is quite similar. The difference, it's especially here, is the saturated time, saturated period, that you have at least 30 consecutive days that soil is saturated. So all voids are fulfilled of water. And we also saw the anthropic horizon. That's a human horizon. It's a horizon that's produced by man. And we can saw this horizon, the surface diagnostic horizon, in cultivated sites and flooded sites like rice cultivation areas where soil is under the water table, and we saw a high accumulation of organic matter, but it's not so high like the Hestic horizon. So here the organic carbon, it's less or lower than 20%. So the organic carbon here could be high, but it's lower than 20. Because if I found a horizon that present a higher, equal or higher content of organic matter, I should describe it like a folic or a Hestic horizon, okay? So here the dendritic horizon should present organic carbon lower than 20%. In these areas, we saw the influence of water from the water table, and we saw the dark colors, some structures, some aggregation here. We also can find some gray colors and some red and yellow models that indicate the influence and the oscillation of water table. Okay. And we discussed about some diagnostic criteria. That's especially color. You should present a low value and a low chroma because they should present dark colors. Okay. And they could present they could be a buried horizon or a surface horizon with a platy or massive structure below this surface horizon. They could present the optomorphic features, these colors, these red and yellow colors that we can see here, because the oscillation of the water table, and we can see a thickness of at least 15 centimeters. We finish our last class discuss about the Arctic horizon, and the Arctic horizon, it's also a horizon produced by man. They are formed under deep cultivation of soil and intense fertilization. So a high incorporation of human and animal residues like limestones, organic residues, organic matter, the residues from other cultivations, they are mixed in the soil. And when we have influence of humans for a prolonged time, for a long time, you could identify this Arctic horizon, like a garden horizon. We can see here the influence and the creation of this Arctic surface horizon by the agriculture in this area. And here we can see these dark colors. And the diagnostic criteria for the identification of the Arctic horizon are low chroma, because the dark color, a minimum content or at least 1% of soil organic carbon. So the organic carbon, at least 1%, should present higher content of phosphorus, because in general, humans incorporate materials with a lot of phosphorus. We should present a high base saturation for at least 50% or the half, because the humans, they generally act to increase the base saturation. So we should present a dark horizon with a lot of phosphorus and a lot of nutrients. And we discussed what is base separation in the last class. To remember, we have the cationic exchange capacity, and this capacity could be described as the total charge quantity that soil possesses. So it's the quantity of nutrients, of charge that soil could host, okay? And when we think that soil possesses several charges, several negative charges, we can discriminate these charges which neutralize some nutrients like calcium, magnesium, potassium, and sodium, and those charges that neutralize some acids like hydrogen and aluminum. So I can quantify how many charges neutralize nutrients, and I can quantify how many charges neutralize acids, hydrogen and aluminum. If more than the half of these charges neutralize bases, I have a high base saturation, because means that at least half of these charges are neutralized by bases, by nutrients, that these guys here. If I have a low base saturation, means that I present several charges, several negative charges, but just a few of them neutralize nutrients, and several, the majority of them, neutralize hydrogen and aluminum. Okay, JJ, but why this is important? Because if I possess, if I'm discussing, if I present a soil with a low base saturation, means that the natural fertility of this area could be low, because I don't have a high content of nutrients. I don't have a high content of bases. And probably this means that this soil is deeply wetted and not influenced by man, not changed by man. And if I have a high base saturation, means that this soil is a soil that's formed from apparent material that's rich on bases, like a basalt or gabbro or other rocks, and this rock, or this soil, I'm sorry, this soil has incipient weathering, incipient leaching of these bases. So it's a soil formed in dry conditions, or a very young soil, or soil that leaching is not so deeply and intensively act in the soil, okay? Or is a deeply wetted soil, but which was affected, mixed, changed by humans, okay? So the base saturation is a very good measure to identify some soils. If I have a low base saturation, I can understand that that soil is a deeply wetted soil, and the natural fertility could could be low. I said could because we have some physical properties that influence the natural fertility. But if we think only in the chemical soil properties, soil that possess a low base saturation possess also a low natural fertility. But if we only think in the chemical soil properties, okay? If we think in the physical soil properties, we think fertility as a broad and general definition, we should understand that these soils could possess a low natural fertility because maybe the physical soil properties are very good and we have a kind of equilibration between physical and chemical soil properties. Okay, and in general, soils and surface horizons that are affected by man, they present a high base saturation because we generally try to increase the base saturation. How we do that? We increase the pH. If we increase the pH, we release these hydrogens in the surface of the clays, and now we have, let me show on the first moment, for example, this is a natural soil. The first condition, we have a lot of hydrogen and aluminum. A very low pH, acidic soil, and just a few calcium, okay? And if we add limestone and have a second condition, several hydrogen ions will be released from the surface of clays to the liquid phase. So now several of these charts are available to be neutralized by nutrients. So some nutrients could be neutralizing and sorting of this clay particle. So the human activity, when we add limestone, when we increase the pH, we are just trying to release, to remove these hydrogens in the surface of clays and try to absorb some nutrients in the surface of these clays. Why? Because once these nutrients are absorbed to this clay surface, now the plants could access these nutrients. So the roots could access this calcium or potassium or magnesium and grow up. Okay? So again, the Arctic horizon present dark colors, a low value and a low chroma, at least 1% of soil organic carbon, at least 120% or 20 milligrams per kilo of phosphorus. Sorry, someone's trying to say something? Someone's trying to say, can you hear me? Okay. Oh, please just say you can hear me.
I can hear you, Gigi.
Okay, okay,
I, I can hear you.
okay, okay. Just to know, because I heard something and I'm not sure if I'm online. Just share my screen again. Just a minute. Okay, okay, okay. It's good. My internet signal is not good today, and okay, okay. So again, the Arctic horizon present dark colors, a low value and a low chroma, at least 1% of soil organic carbon, at least 120 milligrams of phosphorus per kilo of soil, kilogram of soil, a high base saturation, a high content of nutrients, at least 20, 25% of exposed area, which evidence activity of animals like animal pores, coprolites, or other traces of animal activity in the soil, in the surface horizon, and a thickness of at least 20 centimeters. Okay, so let's do again a kind of differentiation of each one. The photic horizon and the hestic horizons, they should present a high content of organic carbon. A high, how much high? At least 20%. And the Hortec, we just need 1%. So it's of course less than 20% and equal or higher than 1%. This is the range to Hortec horizon. Okay, dendritic horizon, they should present some colors that evidence reduction and water table influence. And here we don't present these conditions. We just have a low value and a low chroma. So it's the difference between them. And now we can see the irrigate horizon. This is a horizon, surface horizon, that's formed by irrigation. So if we add water in the soil, but it's a not very good water. It's a water that's sediment rich water. Okay, so we add water by irrigation, but we also add sediments, solid particles. And if this area, if this site, it's above its influence of irrigation for a long time, we start to create, to accumulate some solid materials in the surface and create a horizon, a surface horizon. Like this, it's quite easy to see in these cases that we have here, you can see here, a brown color or dark color. And here we can see a gray color. So even in the surface, we can see very distinguishable colors, easily differentiated because the influence of irrigation, and because these sediments, we could also see other changes. Okay. The hygradic horizon is a mineral material. It's composed by mineral materials. So the organic carbon should be lower than 20% as the Arctic horizon. okay? And it should present structure, so we need to see aggregates or pads, okay, or at least a clotted structure. We talk about that in the classes that we discuss the soil properties, soil morphology, okay? And it should present a clay content of at least 10% relative or, and I'm sorry, 3% in absolute conditions higher than the layer below this surface horizon. So let me show. We have a soil here, and we have a horizon here and another horizon, and this horizon number 1 and number 2. And this horizon, we present something like 50% of clay. And in this second horizon, we present something like 32% of clay. So this first horizon present 50 minus 32, we have at least 18% of clay, a higher content in comparison from the second horizon. So we have at least 3% of clay attended. So this first horizon should present at least 3% of 3% higher than the second horizon. Okay, this is one of these conditions. So this first horizon should present at least 3% higher clay content than the second horizon, or the horizon that are below, that was buried by these sediments that are added by irrigation. Okay, so it's quite interesting to say, to understand that this irrigatory horizon, it's composed essentially by clay that was added in the soil surface by irrigation. So how clay is a very thin and light particle, it could be easily moved. It was added by irrigation and form a clayey horizon in the surface in a material that was buried and present a lower content of clay. Okay, this difference of clay content should be at least 3% in about absolute ratio. So we should just calculate the difference between the clay content of this horizon and this horizon. And if the difference is equal or higher than 3%, so we could present a irregular horizon. And the clay content should be 10% or higher in a relative condition to present a irregular horizon, to follow a irregular horizon criteria. How can I calculate this? We just need to calculate a ratio between these two contents. So if the first horizon present 50% of clay and the second horizon present 32% of clay, we just need to share this, and I'm not good on math, so let me calculate this. Yes, it's it's a dot, I'm sorry, 1.62. So I have at least in this condition 15% of higher clay content in the first horizon in relative terms. So I have a difference of content of at least 3% in absolute way, in absolute terms, and at least 10% higher content of clay in relative terms. So we should follow these two conditions, okay? This relative term that could be calculated from a share, a ratio, between the clay content of the surface horizon and the clay content of that buried or subsurface horizon. And the second one is just a very easy math that we need to calculate the clay content of the surface horizon minus the clay content of the buried horizon. So these two conditions should be followed, these values, so we can follow the criteria to identify the irregular horizon. Okay, this could follow the clay content or the fine clay content, because some researchers, they also measure the content of fine clay. That's the thinner part of clay, okay? So we can measure the total content of clay or the thinner part of clay and just compare the surface horizon and this buried horizon. So in this case, I just need to quantify the content of clay or fine clay here and compare with the content of clay or fine clay here. And I can understand if they follow these criteria here or here. You can see or here. So we don't need to follow these both conditions. It's just A or B. Okay? Here we have the end. So we need to present some structure. We need to present an increase of the clay or fine clay content. And we need to calculate the differences in the sand content, the medium sand content, or the fine sand content, or very fine sand content, and silt content, and the clay content, and the carbonate content for at least or for less than 20% in relative cases and 4% in absolute conditions. So these differences should be lower than 20 and 4%. In relative, calculating from a radio, and absolute, calculate from a minus subtraction condition, okay, in absolute term. So we should follow this condition, this condition, this condition, and we should present at least 3% of soil organic carbon. So you can see that's not so much, but you should present at least this content. And a weighted average of at least 0.5% of soil organic carbon. So if we present like 1 Y horizon and two Y horizon, we should calculate wave average according to the depth of each horizon, and this average should present at least 0.5% of soil organic carbon. We also should present evidences of animal activity in this horizon. We should present some evidence that land surface was being raised, okay? And we should present a thickness of at least 20 centimeters. So you can see that we have just eu tô em aula, será? Ok, beleza. So I'm sorry. So we have 7 criterias, and all of them should be followed. So you can see it's not a very easy to identify a Y horizon, but we can find a lot of them if they follow all these criterias. Okay, so should present aggregates, should present increase of fine content, shouldn't present increase of coarse fraction, should present a minimal content of soil organic carbon, should present some evidence of animal activity, should present an evidence of land surface, a raised land surface, and should present a thickness of at least 20 centimeters. So they should present these 7 conditions to be classified as a Y horizon. It's quite easy to differentiate them from the Y horizon than the other ones, because again, the folic and the histic, they should present at least 20% of organic carbon, and this horizon couldn't present because it's a mineral material. So it's quite easy to differentiate folic, histic, folic, histic, and Y. The anthratic horizon is formed in conditions of water saturation, stagnant water. And here I can't see any influence of this condition. We don't talking about water table influence, so it's quite easy to differentiate. The Arctic and the Y horizons, they have several differences, but it's quite easy to differentiate them because the Arctic horizon needs at least 1% of organic carbon, and we have at least 0.3%. So if we present a horizon like 0.5 or 0.7, we don't have a Arctic horizon, but we could present a Y horizon. And the Y horizon present an increase of the clay content in the surface and didn't present an increase of coarse fraction in the surface. The Arctic horizon, we can't see any evidence of variation of texture of the content of the fine particles in the surface of subsurface materials. Okay, someone raised the hand. Just a moment. Oh, please, Nadima, open your microphone.
Okay, JJ, can you hear me?
Yes, very good.
Okay. When these horizons, when they change to another one, maybe due to continuous usage or continuous plowing for some human-induced ones, will they still retain the original properties or do they change? Do everything change?
Okay, we, of course, we can see in the field that they could change from one to another, but it's not so simple because they are not in straight line of evolution. Like they are not following the same way to 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 soil formation, to increase of thickness or increase of our soil organic content. They have specific soil properties and specific soil process. For example, let me show you again. The hydric horizon is formed by irrigation or water that it's rich in sediments. If we see the comparison with Arctic horizon, here we don't have a high influence of irrigation and increase of particles, thin fraction in the surface because this irrigation. We also have the anthropic influence in these both horizons, but in one case, we have just a mix of materials with limestones, organic residues, and the other one, we have irrigation and irrigation that increase the content of fine particles in the surface. So they have different process. They have different process that create different horizons. So we could see
Okay.
in the field that one horizon could change or evolve to another one, like an Arctic horizon could change through time and follow some properties that now we can classify it like a hydric horizon, but it's not so common because they are formed in different conditions. Okay.
Okay.
Okay. We shouldn't think that soils follow a straight line evolution way. Soils and the horizons could be formed in different conditions. So don't think that we have initial incipient stage of evolution and all soils are formed from this condition, from this position, the position A to position B, and then the position C and D. No, they can present several ways and they can change its properties through time because soils are formed by the soil formation factors interaction, and these factors could interact in different in numerous and high number of possibilities, and so we can change the soil properties a long time very easily. So don't think that soils follow a specific line to evolution. It's not a good way to understand how soils can change through time, okay? We have another surface diagnostic horizon. It's the pelagic horizon, and the pelagic horizon is composed by a mix of organic materials in the surface. Okay, it's quite common in Europe, especially in ancient soils. They are not related to incorporation of limestones and mineral materials. They are especially related to organic materials. So we can see easily this dark horizon formed by incorporation of grass residues and herbaceous vegetation residues into the soil to compose a surface horizon that's rich in organic carbon. Okay. In this case, it's very interesting to see that we present a low base saturation. So the difference between the Arctic and the pelagic horizon is essentially that Arctic horizon we possess the incorporation of organic materials and inorganic materials, and these inorganic materials increase the pH and increase the base saturation. Base saturation symbol is just V. So if you see this letter, V is the symbol to base saturation, the symbol for base saturation. So the Arctic horizon presents a high base saturation and a high pH because the humans incorporate inorganic materials like limestone, and so we can see a dark horizon but a high pH. In the pelagic horizon, we just incorporate organic residues, so the pH still low or even can be more acid because the organic matter produce acid, produce hydrogen. So if you add organic matter in a very high content in the surface horizon, you also are increasing the quantity of hydrogen. So you are decreasing the pH of that horizon. Okay, so the pelagic horizon is formed by the mixture of organic residues in the surface, and this gets a dark color, a high organic content, and a low base saturation. Again, please don't forget that this high organic carbon should be lower than 20%, because if we measure the organic carbon content here in the organic carbon content like 25% or 22%, so this horizon, it's a folic or histic horizon. It's not a pelagic one, okay? But if the content it's lower than 20%, so could be a pelagic horizon. A pelagic horizon is a horizon that's composed by mineral materials. So again, the organic carbon content, it's lower than 20%. Okay, this is a very important criteria that we should always follow. We always should look, the first moment, look the organic carbon content in the surface horizon, because if this content's equal or higher than 20%, so we can understand that we present a folic or histic horizon, of course, depending on the soil moisture regime and the thickness of this horizon, okay? The pelagic horizon also presents a texture of sand, loam sand, sand lawn, or a combination between them. So a pelagic horizon did not present a very thin texture, don't present a high content of clay, okay, because it's a material that essentially organic material that's incorporated. We don't add mineral material. They could present artifacts that are materials created by man that are incorporated in soil, or they could present a high content of phosphorus, or they could present hook marks or plug layers, like evidence of agriculture activity. Okay, so we should present a high content of phosphorus, artifacts, or any evidence of agriculture activity. We also should present low value and low chroma. Of course, we are increasing the content of organic carbon, so I hope that we should see low values and low chroma. It should present at least 0.6% of soil organic carbon. So the organic carbon should be equal or higher than this. It should present a base saturation lower than 50% unless the soil has been limited or received mineral fertilizers. In this case, because a recent modern action I saw, in this case, we can make exception, okay, but it's not so common. Generally, don't receive these mineral fertilizers, okay. They should also evidence that land surface was being raised, and they should present a thickness of 20 centimeters. So you can see again, a pelagic horizon has at least 7 criteria. We have at least a texture with a lot of sand, artifacts, a high phosphorus content, or any evidence of agriculture activity, low values in chroma, at least 0.6% of soil organic carbon, a low base saturation, evidence of raised land surface, and a thickness of at least 20 centimeters. Oh, JJ, it's a lot of information. Should I remember everything? No, you don't need to remember to record all these criteria, all this information. You just need to remember what is, in a general way, a pelagic horizon. So we can go to the field, see a horizon, and okay, this seems a pelagic horizon. Let me check if this horizon that I'm describing in the field follow all these criteria to be a pelagic horizon. So I can see in the book, okay, these horizons follow this, and this. Okay, this is a pelagic horizon. Or that horizon that we are describing in the field follow all these criteria, but did not present this thickness. So, okay, it's not a pelagic horizon. It should be other horizon, other diagnostic horizon. Let's see which could be. And we start to think again and start to try to identify a horizon, diagnostic horizon, that all the criteria are followed. Okay, so you don't need to remember all this information, especially the thickness. Thickness, even I don't remember. I always need to check this because it's a lot of information. I prefer to record the definition and some very important or relevant soil properties that could help me to identify this horizon. And then I will check in the book, okay, it's following all the information, all the criteria. Is this horizon, is that horizon? Okay.
Okay.
Other horizon, other surface horizon is the Pratic horizon. And the Pratic horizon, it's a very interesting horizon. It's a very interesting surface diagnostic horizon. It's also it's formed by humans, but in this case, They are formed by ancient indigenous activity that increase charcoal content, bones content, artifacts, coal. So as you can see here, this dark horizon is a pratic horizon because we can see a lot of shales here that show us that this material was formed by man. It's not close to the sea, so it's not a natural deposit, okay? And here, it's a human bone. So it's a soil that in the past was formed by human activity, that it's always eating food and accumulating the residues in a place like a waste deposit, and this waste deposit formed a soil, a horizon, okay? It's a very important horizon to identification of anthrosols. We'll discuss about them after in the next classes. Of course, all these diagnostic horizons, the surface diagnostic horizons that are discussing are quite related to the anthrosols. The other example of pratic horizon, here we have some artifacts. They are some materials that were incorporated by human. They are buried, and after that they are fired by the men, the human that buried this material here. They are very common in Amazon rainforest, but we also can see these horizons in savannas, in Brazilian savannas, and in dry forests, and the wetlands of Chaco in South America. They are very common. They are very, very common because they present these dark colors and a high natural fertility. In the past, they are called black soil, black indigenous soils, but today we are just say pratic horizon, okay? And this pratic horizon consists of mineral materials, so the organic carbon, it's lower than 20%. The color is dark, so you present low values and low chroma, okay? You should present at least 0.6% of soil organic carbon. You should present a high content of calcium and magnesium and phosphorus. And why? Because we have bonds and we have shales that release these materials, release these nutrients in soil. So the pratic horizon should present this high contents of these materials. It's not unusual to identify some pratic horizons that has more than 1,000 of milligrams of phosphorus per kilogram of soil. And some of them present higher contents of more than 4,000 milligrams of phosphorus per kilogram of soil. So we present a very high content of phosphorus, calcium, and magnesium. Okay? We also should present a content or at least 1% of visible black carbon, because the coal, it's very common. Or we should present any kind of carbon that are related to black carbon, that we can see like ash there, okay? And we could calculate the ratio between this inorganic carbon and this organic carbon here. So the presence of these materials, they should be higher, okay? And of course, a thickness as usually at least 20 centimeters. So the Pratic horizon is that horizon that presents dark colors, a relative high soil organic carbon content, a high content of calcium, magnesium, and phosphorus, elements that could be wherefore could be released by the weathering of bones and shales, should present inorganic carbon too from ash, from coal, and should present a thickness of at least 20 centimeters. Okay. The difference between the Pratic horizon and the folic and the histic horizons. Folic and histic should present at least 20% of organic carbon. The Pratic horizon should present lower contents of organic carbon. So the difference between folic, histic, and Pratic horizon, it's very easy to identify. Oh, I'm sorry. The difference between these horizons, it's quite easy. The difference between the Pratic and the Antratic horizon is that the Antratic horizon is related to influence of water table. Here, we don't see any influence of water table. We don't see gray colors. The difference between the Pratic and the Arctic horizon, the Pratic horizon is related to high content of calcium, magnesium, phosphorus. We don't present a high base saturation, could be higher, could be low. It's not related to a modern change of the soil surface. It's related to an ancient change. They are changed, they are formed by humans acting in the past, not in a recent time. So the Pratic and the Arctic horizon, they are very different, okay? Irrigate and the Pratic, we don't see any influence of irrigation here. We don't see increase of fine clay or clay in the surface. It's not a buried horizon, so it's not the same, okay? So it's quite important to understand every time, how can I differentiate one diagnostic horizon to other? So we don't need to record all the information, all the criteria, but we need to know how can I differentiate one from another, okay? Other
Okay.
horizon that's quite important, other surface diagnostic horizon that's quite important to know is the Taric horizon. The Taric horizon is a horizon that's formed by the addition, the addition or the mixing of mineral and organic materials that form this little terraces. It's also very common in South America, especially in the Andean terrains. So the mixing of sand, limestone, mud, loess, and other materials, organic and mineral or just mineral materials, produce this little flat surface, and so form the Taric horizons. So it's quite common to see something like this. And these little terraces are formed by mixing of materials that create this flat surface so we can cultivate in these flat surfaces. So the relief generally are just like this, and the humans, they mix materials to create this kind of surface. And now the erosion, it's lower, and we can cultivate here very easily. These are the creation of the terric horizon, okay? To model, to change the slope, creating some little terraces in the surface, mixing organic and mineral materials. You can see here, with a mix of this material over this limestone. Oh, just a moment, someone is asking in the class. Okay. So here you can see this red material, red mineral material that's overlaying this limestone. And this is the photo of the one specific soil profile very close to here. So we can see very easily, very easily these differences of this material that was mixed over the rock and saprolite that was formed in situ. So the humans, they create this flat surface mixing organic and mineral materials, and here we can see a surface diagnostic horizon that was produced by man, mixing materials and creating a terrace. To identify a terric horizon, we should understand that it's composed by mineral materials, so the organic carbon it's lower than 20%. It should present evidence of addition of materials, okay? It should present at least should present less than 10% of artifacts, because it's not a pratic horizon. It should present at least 0.6% of soil organic carbon. It should present a base separation of at least half, so high base separation. Should present evidences that the land surface band has been raised, has been changed, and should present a thickness of at least 20 centimeters. So it's a mixing of mineral and organic materials that compose a horizon that did not present a lot of artifacts, present a relative high content of soil organic carbon, present a high base saturation, and is related to a formation of terrace, and of course present a thickness of at least 20 centimeters. So it's quite easy to differentiate the terric horizon from the others because it possesses specific conditions that should be followed. Other surface diagnostic horizon that's quite important too is the molic horizon. This molic horizon is not formed anymore by the humans, so it is formed by nature, by only the interaction between the soil formation factors. Okay, and this molic horizon is a relative thick horizon. As you can see, this is the molic horizon. It is well structured, so present a strong grade. As you can see in this picture, we can see that the majority of the material, the fine earth, compose pads it composes aggregates. And just a few of these fine materials are not forming pads, are not forming aggregates. So we present a strong grade. Okay. We present a dark color, as you can see here. As you can see here, the molecular horizon should present a dark color. And it also should present a high base saturation. So the V value should be equal or higher than 50.5. You should present a high biological activity evidence. So this horizon is created by an intense and deeply action of animals in the surface, animals and of course vegetables, but especially animals, termites and earthworms. They create this diagnostic horizon, and it should present moderate or high organic carbon content. Okay. This molecular horizon, it's a very interesting horizon because in this case, the organic carbon is related to organic and metal compounds, complexes. So the organic carbon here is preserved by interaction with some elements. Which one? Especially calcium. So the molecular horizon is that horizon where the organic carbon present in the surface horizon is related to calcium content, because calcium forms some organic and metal complexes that reduce the action of microorganisms. So the organic carbon tend to increase or be preserved in this horizon. Okay, so the organic carbon content here is quite different from the folic and histic horizons, because in the folic horizon, we have a high organic carbon content that's related to dry conditions or cool conditions. And the histic, we present a high content of organic carbon, but in this case, the organic carbon is related to water. The stagnation of water, or the water table, or the tidal water favor the accumulation, the increase of organic carbon content. In this case, we have the action of calcium. So the molecular horizon is generally related to parent materials that present a high content of calcium. Okay, which parent materials could we identify, could we say or list that present a high calcium content? The mafic igneous rocks like basalt, and some chemical sedimentary rocks like limestone. So molecular horizon is generally related to limestone or basalt, like in this case. Here we can see some pieces of the rock, the R and C horizons, R layer and C horizons, from the weathering of basalt. And this basalt, the weathering of this material is forming a molecular horizon here. Okay, basalt presents a high content of calcium because it's composed especially by plagioclases. And limestone is composed by calcite. They both present a high content of calcium. So Parent materials that present a high content of calcium could could favor the formation of a surface horizon where we process a moderate to high organic carbon, and this organic carbon is preserved by chemical boundaries, chemical bonds with calcium. To identify the diagnostic criteria to identify a molecular horizon, we should present material that is composed by mineral material, so the organic carbon is lower than 20%, and we should present at least a half of this material aggregation, okay, and this material should present a size lower, equal or lower than 10 centimeters, or a cloudy structure, okay, created by agriculture, should present at least 0.6% of soil organic carbon. It should present low values and a low chroma because it's a dark material, it's a dark horizon. Should present a calcium carbonate equivalent of 10 or 15% and less than 40%. So we can identify here some calcite minerals, okay? It should present in the exposed area a muscle color of these materials, low value and low color, or low value and low chroma, okay? If we present any plug layer, and our organic carbon of at least 1%, or we should present a sum of calcium carbonate and gypsum of at least 40% equal or higher than 40%, and a texture of loamy or coarser class, okay, could be sandy class, is not a problem, and at least 90% of a low value and a low chroma and a higher content of organic carbon, at least 2.5. So we should present this condition or this condition or this condition, and A, B, and C, they differentiate between them according the presence or the absence and the quantity of calcium carbonate. If we present a higher content of calcium carbonate, we demand a higher content of soil organic carbon. If we present a lower content of calcium carbonate, we demand a lower content of soil organic carbon. And if we don't present calcium carbonate, you just need to follow the color and this content of soil organic carbon. So see, if we have a soil with calcite, we should understand that the soil organic carbon should be higher. This 1 or 2.5, depending the quantity of calcium carbonate. If we don't present calcium carbonate, you just need to follow aggregation, at least 0.6% of organic carbon, and a dark color. Only these three conditions. If we have calcium carbonate, we should present aggregation, we should present dark colors and a content of calcium carbonate, or in this case, dark colors and a higher content of calcium carbonate. Okay. This is a horizon that's quite easy to differentiate between the other ones, because we are always saying that this horizon is related to limestones or igneous mafic rocks. So if you know the parent material, help you a lot. And of course, we should understand that all these materials are related to a strong grade and dark colors and a moderate to high organic carbon. Oh, we also have these 4, 5, and 6 criteria. Okay, if a layer is present that corresponds to the parent material of the molecular horizon, it should present a color that's lower than 4, and the content of organic carbon in this molecular horizon should be at least 0.6 higher in absolute terms from the parent material. So if we present here a horizon that I think that the molecular horizon, another horizon like A and B, and here's the rock, and here's the parent material. Okay, here's the parent material. I should analyze here the organic carbon content and should analyze the color of this material. The color should be lower, the value of the color should be lower than 4, and I should compare the organic carbon content in the surface horizon and rock. And the difference between the organic carbon here and here should be at least 0.6. Like if I present here something like 2% of organic carbon, and here present something like 1% of organic carbon, the difference is 1%, so it's higher than 0.6. So, okay, this is a molecular horizon. This follows this criteria. It's not a problem. But if I present her surface horizon, that here we have 2%, and here in the rock we have 1.8% of organic carbon. The values are very close. The difference is only 0.2%. So we did not follow this criteria. So it's not a molecular horizon. Okay. The base saturation should be at least 50%. Okay. So in a wave average, okay, so if we represent more than one molecular horizon, like A1 and A2 and now a B horizon, we need to calculate the average, the wave average wave according to the depth, the thickness of these materials. So the base saturation should be equal or higher than the half, than 50%. It should present a thickness of at least 10 centimeters if this surface horizon it's over rock like this. So I have here 10 centimeters or 12 centimeters. So you are following the criteria to identify the molecular horizon. This could be on continuous rock, horizon, technique, hard material, material created by man, cryic horizon, petrocalcic horizon, petroduric horizon, petrogypsic horizon, or petroplantic horizon. We will discuss about this horizon in the next classes, okay? Or it should present at least 20 centimeters. So if the molecular horizon it's over a B or a C horizon, it should present at least 20 centimeters, okay, to follow all the criteria to identify the Mautic horizon. So remember to differentiate the Mautic horizon from the other ones, you just need to think, I really need dark colors. Oh, sorry. I really need dark colors. I really need a high content of calcium, maybe calcite, calcium carbonate, okay? I should present a moderate or high organic carbon content. I should present a high base saturation. And I should present a higher organic carbon content when I'm comparing to the content of the parent material. So this surface horizon should present a higher content in comparison to the parent material. And of course, we also have the thickness of at least 10 centimeters or 20 centimeters according to the overlaying material. We also present the Chernich horizon. The Chernich horizon, it's a special Mautic horizon. It's like a Mautic horizon, but it's darker, present higher organic carbon contents, demands a greater thickness, and demands a minimal content of fine fraction. So the Chernich horizon couldn't present a high content of coarse fractions like gravels or stones or rocks, like I can see here. In the Mautic horizon, I can see a lot of gravels and the Chernich horizon couldn't present this. It's just a fine material. So it's darker, it's thicker, presents higher contents of organic carbon, and it's thinner or present a higher content of clay. And here other example, okay? So we have a lot of diagnostic criteria, okay? So again, you don't need to record everything. You don't need to remember everything. Just remember that the Chernich horizon is a special Mautic horizon. So if you are in the field trying to classify a soil, you just need to check the book and check if all the criteria are followed or not, okay? So in this case, we have at least fifth or half of the material composed by fine earth, okay, which should present a strong grade, which should present a higher content of soil organic carbon. We should present dark colors, so low values and low chroma, okay? And if we present calcium carbonate, if we present calcite in this horizon, the organic carbon should be higher than this. So if we have calcium carbonate in soil, the organic carbon should be higher in these situations, okay? The base saturation still higher than the half. We also should present a low value of the parent material and a higher content of organic carbon of the surface horizon comparing to the parent material, and a thickness of at least 30 centimeters. So it's thicker than the Mautic horizon. So you can see it's quite similar to Mautic horizon, but here we demand a content of fine earth, We again demand a strong grade. Here we demand a higher content of soil organic carbon. We also demand, like the Molic horizon, dark colors, and the organic carbon varies according to the content of calcium carbonate. We also demand a higher content of organic carbon in the soil in comparison, comparing to the parent material. We also present a high base saturation, and now we present a higher thickness. So we have only three chains that could differentiate the Chernic and the Molic horizon. So if you are in the field, you can think in these two horizons in the same way, and after describe all the soil, so the thickness and the content of organic carbon, so now, and the content of fine fraction. So now we can understand, okay, this is a Chernic horizon or a Molic horizon. Okay, in the field we could differentiate then after this soil description. Could be very easy to do this. We also have the umbric horizon, and the umbric horizon is that horizon that possess moderate to high organic carbon contents, like the Chernic and the Molic horizon. It's also thick, it's also dark, but in opposite to the Chernic and Molic horizon, it possesses a low base saturation. So the umbric horizon, it's also a natural horizon. It's formed by the interaction between the soil formation factors. It's not formed by the human activity, but we present a high content of organic carbon, but a low saturation. In this case, the organic carbon content, it's quite related to the action of clay, the clay fraction, and aluminum. The clay fraction, it helps the creation of pads, the aggregates, and inside these aggregates, the organic matter could be preserved against the action of the microorganisms. So in soils that represent a high content of clay, we could create a horizon, a surface horizon that possesses a high content of organic carbon, because clay help or favor the increase of organic carbon content. Okay, and we also can see this umbric horizon in soils that possess a high aluminum content, because aluminum is toxic to the microorganisms. So if the soil possesses a high aluminum content, the microorganisms activity is low, so they don't act very fast, and they don't decompose the organic matter very fast. So we can create an umbric horizon. Okay, you can see here they are very thick with a lot of roots, dark, a high content of organic matter, but a low base saturation. And which criteria should we follow to identify an umbric horizon? Well, it should be very aggregate. The aggregation should be strong, so we should present a strong grade. We should present at least 0.6% of soil organic carbon. We should present dark colors, so low values and low chroma. We should present or we should present a texture that's loamy sand or coarser, so a texture with a lot of sand and dark colors. and a higher organic carbon content in comparison with these materials. So you can see, if we have a soil that presents a clayey or silty or loamic texture, we just need to present 0.6% of soil organic matter. But if we present a sandy texture, we should present a higher content of soil organic carbon. And of course, dark colors like here. Okay? And in this case, this layer should present a value that's lower and possess a higher organic carbon content comparison to the parent material. So like the churnic and the molic horizons, the organic carbon content in the surface horizon should be higher than the parent material and should be darker than the parent material. And in this case, the base saturation should be lower than 50. So in this case, we present a low base saturation. So the churnic and the molic horizons, they are related to a moderate to high organic carbon associated to a high base saturation. And the umbric horizon in opposition present moderate to high organic carbon content and a low base saturation. Because here the organic carbon has been preserved by calcium, and here the organic carbon content is preserved by aluminum and or clay fraction. So we have different processes, and because of that, we have different horizons. Okay?
Okay.
Other criteria that should be followed, it's just the thickness. If the umbric horizon is the surface horizons, it's overlying rock or a material created by man, or cryic or petroduric or petroplantic horizon. We'll discuss about this horizon in the next classes. It should possess at least 10 centimeters. But if this umbric horizon is the surface horizon, it's above a B or C horizon, should present at least 20 centimeters of thickness. Okay, so again, you don't need to remember all this information, all these details. You just need to remember how to differentiate one horizon to other. Okay?
Okay.
Okay. Now have to finish our class. We have more 3 surface diagnostic horizons, but we'll discuss these in the next classes. Again, please try to read the material that I share in the Google Classroom about the World Reference Base for Soil Resources. There you can find all the surface diagnostic horizons, and you should read about them. In the next class, I will finish the surface diagnostic horizons, and I will share an exercise with you all, asking you to identify which surface diagnostic horizon we have in the field. So I will present you some pictures and some data, so you should understand how to identify the surface diagnostic horizon and classify that horizon according all surface diagnostic horizons that we have in the WRB. Okay?
Okay.
Okay. Any doubt? Everyone's okay? We have any doubt?
I'm okay.
Okay.
Well, look, I'm fine and well explained.
Thank you. Thank
Just
you.
that it's sort of complex because maybe because it's still new, so it's sort of complex
Yeah,
and
yeah.
huge to comprehend. But maybe when I read through, maybe I will be able to fine tune and be able to differentiate the horizons.
Yeah. I'm pretty sure that's a lot of new information. I
Yeah,
know. Yeah, it's not a problem. So it's why I'm always saying to you, don't worry. You don't need to remember all the details, but
yeah,
try to describe each horizon so it's better. And after that, consult. Okay, check how it's all the criterias to identify this horizon and this horizon. So helps a lot. And you don't be worried with a lot of information. Okay.
yeah. Yes, yeah.
Okay.
All right, so
Okay, people. So see you in the next class with finishing this diagnostic surface horizons and finish an exercise. Okay.
yes. All right.
Bye bye. See
All right.
you.
Thank you. Bye for
Thank you.
Bye bye.
bye.
Thank you, Judge.
Welcome.
Thank you, JJ. Bye bye.